Welcome geometry students to the homework help video, page 260, numbers 10 through 23 and numbers 29 through 32. Please have your books open, please have your homework out, and let's go ahead and get started. For numbers 10, 11, and 12, the directions say, determine whether you can use the HL congruence theorem to show that the triangles are congruent, and then explain your answer. Let's take a look at number 10. Now remember, first of all, to use the HL theorem, we have to have three things. We have to have two right triangles. We have to have a hypotenuse congruent to a hypotenuse. And we have to have a leg congruent to a leg. Now let me very quickly cut and paste that so we can use that for the rest of this video. And here we go. Let's run our little test here. Number one, do we have two right triangles? Yes, we do. Do we have a hypotenuse congruent to a hypotenuse? Yes. Here's a hypotenuse and a hypotenuse. And do we have a leg congruent to a leg? Well, here's a leg with one slash. Here's a leg with one slash. So yes, we can definitely use the HL congruence theorem. By the way, the directions say to explain your answer. I mean, we just did as we went along. I mean, we checked all of these things off, so we're totally good. All right, number 11. I'm going to very quickly, like I usually do, separate these two triangles. And here we go. First of all, we need to have two right triangles, and we do. Here's a right angle and here's a right angle. So yes, we have two right triangles. We need to have a hypotenuse congruent to a hypotenuse. Well, look, here's your hypotenuse right here. Notice both of these triangles shared JL, so we can definitely say that this side here is congruent to this side here. So check. And do we have a leg congruent to a leg? Well, this side here has one slash and this side here has one slash. So yes, we have a leg congruent to a leg. So yes, all three of those things did take place. So yes, we can use the hypotenuse leg congruence theorem. All right, number 12. Now number 12, I'm pretty sure the answer is going to be no. And let's take a look at why. We definitely have two right triangles, so we can check that. Here's a right triangle down here, and here's a right triangle up here. So we definitely have two right triangles. However, here's your hypotenuse right here, and here's your hypotenuse right here. And notice we do not know if the two hypotenuses, if there is such a word, we do not know if they're congruent. So now listen, I'm not saying these two triangles are not congruent. In fact, they are congruent because we have side, angle, side, congruent to side, angle, side, SAS. So these two triangles are congruent, but you cannot use, for your reason that the two triangles are congruent, you cannot use HL for your reason because you do not have one hypotenuse here congruent to one hypotenuse down here. So no, you cannot use HL. Okay, let's continue on and take a look at number 13. What information do you need in order to use the HL congruence theorem to show that these two triangles are congruent? Now, look, let's take a look at what we have. First of all, I'm going to move this down here so I can bring up this right here. Okay, do I have two right triangles? Well, yes, I do. This is a right triangle here, and this is a right triangle here. Do I have an hypotenuse congruent to a hypotenuse? Well, no, I do not. I would have to have this side here congruent to this side here, and I do not have that. So I want to put a check mark here and an X here. Now, do I have a leg congruent to a leg? Well, I do, because notice how these two triangles are sharing a side right here. Okay, so really the two triangles look like this. Here's one of them. If I split them up, and here's the other one, and we can definitely see how this side here is congruent to this side here. So we definitely have a leg congruent to a leg. So it says, what information do you need? in order to use the HL congruence theorem. Well, here's what I need right here. There it is. So there's your answer. You are missing, or in other words, you need an hypotenuse congruent to another hypotenuse. Okay? And that's what we're missing. All right, let's continue on and take a look at number 14. Suppose K is the midpoint. Now I'm going to stop right there and mark K is the midpoint of JM. Now what that means is K is right in the middle of this whole segment. Now if K is in the middle, then that stands to reason that K splits JM up into two congruent segments. So I can definitely say that JK is congruent to KM because K is right in the middle. Name a theorem or postulate you could use to show that triangle JKL is congruent to triangle MKL. Now remember, our options are SAS, side, 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 angle, side, angle, 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 side, and hypotenuse leg. Okay? So let's see what we have here. Well, I noticed right away, remember, if I were to split these two triangles up, they would look like this. And remember, I have 90 degrees here and here, so I know those two angles are congruent because they're both 90. I have this leg here congruent to this leg here, and look, they share the side right here, and so I can definitely state that this leg here is congruent to this leg here. Now I cannot use HL because I do not have a hypotenuse congruent to a hypotenuse, so I cannot use that. But look what I do have. I have a side, then an angle, and then a side. So side, angle, side, congruent to side, angle, side. So what theorem or postulate could I use? Side, angle, side. Side, angle, side proves that these two triangles are congruent. Okay, let's take a look at numbers 15 through 23. Okay, that's going to be 9 problems, and the directions read as follows. Decide whether enough information is given to show that the triangles are congruent. If there is enough information, then state the theorem or postulate you would use. Well, students, here we go. Look at this triangle. We have a side, then an angle, and then a side, congruent to a side, and then an angle, and then a side. So yes, we can definitely state that these two triangles are congruent, and the reason would be side, angle, side. There we go. All right, number 16. Now here, notice we have an angle, and then a side, and then an angle. We have an angle, and then a side, and then an angle. So we have angle, side, angle in one triangle congruent to angle, side, angle in another triangle. So yes, we can definitely state that these two triangles are congruent, and the reason would be angle, side, angle. Let's take a look at number 17. Now notice in 17 we definitely have 3 parts of one triangle congruent to 3 parts in another, but look what we have. It's kind of weird. We have a side, and then a side, and then an angle, a side, and then a side, and then an angle. So we have side, side, angle. And guess what, students? Nowhere do we have a postulate or a theorem that uses side, side, angle. It just doesn't exist. Now, I'm not saying that these two triangles here are not congruent. Maybe they are, but we cannot state for sure they're congruent, but it's because we cannot use one of our 5 ways: side, 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 angle, side, angle, 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 side, and hypotenuse leg. None of those can be used, so no, we cannot state for sure that these two triangles are congruent. Okay, number 18. Now here, if you'll think about it for a second, I'm going to go ahead and trace over these and pull these two triangles apart here. Now notice we have 2 tick marks here and 2 here, 2 slashes, 1 slash here and 1 slash here, and notice these two triangles share this side right here, so I can say this side here is congruent to this side here. So look, what do we have? Side, side, side. three sides of one triangle congruent to three sides in another triangle. So yes, we can definitely state that these two triangles are congruent by side, angle, side. Okay, number 19. Now again, I think it would be very helpful if we just took about 20 seconds and split these two triangles up. Okay, and here's what we have. We know we have a right angle here from right here, so we know we also have one right here, so a right angle here. So those two angles are congruent. We know we have one slash here and one here, so we know that those two angles are congruent. And then do not the two triangles share this side here? Sure they do. So I can put a slash here and a slash here. Look what we have. We have angle, angle, side, congruent to angle, angle, side. So yes, we can definitely state that these two triangles are congruent, and the reason would be angle, angle, side. Let's take a look at number 20. Now in your book, someone's written in my book, and that's why you see a slash here and a slash here, but in your book you don't have that. But I'm going to go ahead and say this to you. Notice that when two lines intersect, remember when two lines intersect like this, the vertical angles are always congruent. Okay, the angles across from each other. And so we definitely can state that this angle here is congruent to this angle here. And of course, notice students, we have 90-degree angles here and here. So here's basically what we have. We have angle, angle, and then side, congruent to angle, angle, and then side. So yes, we can definitely state that these two triangles are congruent by angle, angle, side. Okay? All right, number 21. Let's see if we can't prove that these two triangles are congruent, or maybe we can't. So let's see what happens here. Okay, we know we have a right angle here, so we definitely have a right angle here. So right angle here, right angle here. We know we have a slash here and a slash here. And let's see. Oh, and we know they share a common side right here. So two slashes, two slashes. Now, I know this should be coming to a point right here like this. Now students, listen, notice we have a right triangle, so we might be able to use our HL theorem. Let's see, do we have two right triangles? Yes, we do. Do we have a hypotenuse congruent to a hypotenuse? Yes, we do. Do we have a leg congruent to a leg? Yes, we do. So yes, we can definitely state that these two triangles are congruent by the HL theorem. Okay? All right, let's take a look at number 22. Now this is going to be a really tough one, I'm not going to lie to you, and I probably won't give you one this hard on a test or a quiz, but let's still go ahead and tackle it and see if we can't understand how to solve this problem. See these two arrows here and two arrows here? You should know by now that means these two lines are parallel that I'm extending right here. And notice we have two parallel lines cut by a transversal. Sometimes when you extend the lines you can see it a little better. And so two parallel lines cut by a transversal, and whenever we have two parallel lines cut by a transversal, we know that alternate interior angles are congruent. So this angle here would be congruent to this angle here. Do you see that okay? So with that in mind, since that's true, then what that means is, let me put this back up here again, that means that this angle here, like I just showed you, is congruent to this angle here. All right? Now I'm going to pull this back up here in a second, but for the time being I'm going to come down here, and now I'm going to do something else. Do you see how I have one arrow on this line and one arrow on this line? Do you see that? Okay? And then, so I have two parallel lines cut by a transversal, like this. Now please watch carefully what I do here. I'm going to grab this diagram here and pull it back up here. Alright? In fact, I'm going to get out of the way a little bit. Now I'm going to highlight this And I'm going to turn this. I did not mean to do that. There we go. Now I'm going to turn this, okay? Let me go back down to here real quick. And I'm going to grab this and pull this here. Now we're dealing with, see this angle right here? That would be this angle right here. I'm going to go ahead and put this, well, that'd be this angle here and this angle right here. So watch what happens now when I turn this, okay? That would end up being, now watch, this angle here being congruent to this angle here, and that's right, they're alternate interior angles. Again, you might not be seeing this. I'll admit it's really difficult to see, but and I'm not planning on giving you one this hard on a test or a quiz, but I am hopefully showing you how I know that these angles are congruent. So I can definitely put 2 slashes here and 2 slashes here. So here's what I have. I have a triangle, 2 triangles, and notice they share this side right here. Now I'm not going to split them up this time, but look, in this triangle up here, triangle JLK, we'll call it triangle number 1. I have an angle and then a side and then an angle congruent to, now look at triangle 2 down here, congruent to an angle and a side and an angle. So yes, I can definitely state that these 2 triangles are congruent by angle, side, angle. All right, and then last but not least, number 23. Let's see what we can do here. I think it would help us to split this very quickly. And here we go. We have a mark here and a mark here. We have a mark here and a mark here. And then notice they share a side right here. So I can put 2 marks here and 2 marks here. So it looks like I have a side here, and then an angle, and then a side, congruent to a side, and then an angle, and then a side. So yes, I can definitely state that these 2 triangles are congruent by side, angle, side. Let me grab a quick drink of water here. And let's continue on. Next would be numbers 29 and 30 and 31. 29, 30, and 31. The directions say what congruence is needed to show that the triangles are congruent. Using that congruence, tell which theorem or postulate you would use. Now this is really, really easy because listen to me. They're letting you pick what congruent parts you want to name. In other words, you get to pick one more congruent part. So I could claim that F is congruent to J. So I would state that angle F is congruent to angle J. And now that I've stated that, that's one answer. Now that I've stated that, how could I prove that these 2 triangles are congruent? Angle, side, angle, congruent to angle, side, angle. So you would say angle, side, angle. But that's not the only answer. You could also do it like this. You could say, okay, I'm going to go with side, angle, side. So I'm going to state that GH is congruent to KL. So I'm going to say GH is congruent to KL. And by the way, there's a third way to do this. I'm not going to get into the third way, but there's another way you can do this. So now that I've stated GH is congruent to KL, that's one part of your answer. Now you have what? Side, angle, side, congruent to side, angle, side. So side, angle, side. If this is congruent, if these 2 sides are congruent, then we can use side, angle, side. All right, number 30. Well, I mean, look, students, I would just simply, we already know, I guess it'd be best if I quickly split this so we can see it a little better. Okay, there we go. Now, look, I know I have a right angle here because of this, and I know that I have a right angle here because of this. And then because these two triangles share this side right here, I know this side is congruent to this side. So look, if I can just state that one more part, like this part here, is congruent to this part here, what would that be? That would be PQ congruent to SR. So if I can state that PQ is congruent to SR, then I can use hypotenuse leg. Okay? So I have two right triangles, yes. I have a hypotenuse and a hypotenuse congruent to each other, yes. And I have a leg congruent to a leg, yes. So I can definitely use hypotenuse leg as long as PQ is congruent to SR. And then last, number 31, let's see. We know for sure we can state that this angle here is congruent to this angle here because they're vertical angles. We know that. So how about this? How about I state that WX is congruent to ZX? So I'm going to state that WX is congruent to ZX. Now why did I do that? Because now look what I have. I have angle, side, angle congruent to angle, side, angle. So what congruence or what theorem or postulate would I use to prove that these two triangles are congruent? Well, if WX is congruent to ZX, then I would use angle, side, angle. Okay? And now we're basically done except for number 32. So here we go. Let's quickly do this. First of all, let's go through and do some easy stuff first. I see in my given right here I have BD congruent to FD. Here's BD congruent to FD, so I'm going to go ahead and erase that. It should be your given. And then look right here. BCD and FED are right angles. We'll look right here at 4. BCD and FED are right angles, so I know this is your given also. And then look right here for number. So we've already written this in our given right here. We've already written this in our given, our proof right there. Now look at number 2. The reason is given. So if your reason is given, and you probably wrote your given over here, well, it should be this right here. D is the midpoint of CE. That's the only part of the given that we haven't used yet. Let me go ahead and do that and then make this eraser a little smaller. So there we go. D is the midpoint of CE. Now look at this last thing that you just wrote, number 2. Step number 2. D is the midpoint of CE. Now come on, look. D is in the middle of CE. Now if D is in the middle of CE, that means that CD has to be congruent to DE. And look at this reason for number 3. Definition of midpoint. Now if they're putting definition of midpoint, then over here you know what they're probably putting? Look at step 2. We said D is the midpoint, so step 3 is probably going to be CD is congruent to DE. Let's take a look and see if it is. Yep, CD is congruent to DE. So because I knew D was the midpoint, then my next step was to state that CD is congruent to DE, which is definition of midpoint. Now we come down here to number 5. Look at number 5. Whatever you put here, the reason was definition of right triangle. Now come back over here. Look at step 4. We said BCD and FED are right angles. So we stated we have a right angle here, and we stated we have a right angle here. Now why in the world would you state that you had right angles? Well, one reason might be so that you can state that this triangle is now a right triangle and this triangle is a right triangle. Okay, which would make sense because look right here, definition of right triangle. And so what I would think we would put here is, yep, BCD and FED are right triangles. So triangle BCD and triangle FED are right triangles. And I know that because definition of right triangle, as soon as I stated that I had right angles, then I can definitely state that I have right triangles. And now we're going to state that these two triangles are congruent. Okay? Now, that means we're going to have to use side, 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 or side, angle, side, or angle, side, angle, or angle, angle, side, or hypotenuse leg. We've got to use one of those 5 reasons if we're going to state the triangle BCD is congruent to triangle FED. Now, look what we have. We have right triangles. We can see that. We have a hypotenuse congruent to a hypotenuse. We have a leg congruent to a leg, and we have 2 right triangles. HL. That's got to be it. There it is, HL congruence theorem. So we could state that these two triangles were congruent because of hypotenuse, leg theorem. Okay? I hope this video has been a help to you. I hope that you're working hard on your homework. Please continue to do that, and call or email if you have any questions.